All right, benchmark FRQ practice, calculator required. Let's look at it. In large town, the local cable company experienced a service outage that prevented residents of the town from being able to watch their local football play on the TV. As the local cable began to receiving phone calls to report the outage, residents were placed on hold while operators attempt to respond to the customer calls. The number of customers on hold with the cable company is given in the table above, the selected time following the service outage. So if you look at it, like after 3 minutes, there's 14 people in hold. After 8 minutes, 25. After 12 minutes, there are 18 customers on hold. Letter A. Use the given data to write 3 equations that can be used to find the value of A and B and C. Remember, this is the one that you don't even need a calculator. This is the easiest point you will get on FRQ. So the first point is 3, 4. Wouldn't you agree that means the input is 3, output is 14? So what we're going to do is take the 3, put it where your input goes to our function here, and then set that equal to 14, your output, like this. 14 is equal to A times 3 squared plus B times 3 plus C. Easy peasy. Second point is 8, 25. We're going to do the same thing. Instead of T, we are plugging in 8 in. So 8 times 8 squared plus B times 8 plus C is equal to 25. Third point was 12, 18. 12 goes into T, equal to 18. Okay, so you can write it like that. I'm done. 1 point. I don't do any math. That's all you need to do. You just plug it in for the correct function over here. Letter B, find the value of A and B and C. Remember, folks, this is the calculator requires. I'm going to pull Desmo out, which I hope it works. There we go. I'm going to make it a little bigger. And I'm going to run the regression through the Desmo. So add item table. You have 3 values, 3, 8, 12. Those are your inputs. Outputs are 14, 25, and 18. All right, how to run the regression? You go to this dot, click it. If you look at the problem, so you can't really see it. We want C of t is equal to AT squared. That's a quadratic. So I'm going to go ahead and do the quadratic. This is what I got. So let's quickly make it bigger. I can't see what's going on my screen. Hold on. So hopefully you can see. So A value is over here, right? So negative 0.438889. You can round to the thousands. B is equal to 7.02778. And C is equal to the constant, negative 3.1333. Folks, I'm looking at over here. A, B, C. Okay, so if you look at what I wrote, this is what I wrote. A, B, C. Or you can just put it all together as C of t is equal to A t squared plus B t plus C. So you can write it A and B and C separately, or just put it all function together like that. Letter B. Use the given data to find the average rate of change on hold between t is equal to 8 and t is equal to 12. Remember average rate of change? F of B minus F of A over B minus A. That's how we memorize the generic one. A few things you have to check it. Is my function F on Desmo? I'm going to go and check it for a second. So let me make it big. So this is what we're going to plug it in the calculator. But the problem here is that I'm looking at Desmo. Desmo has no idea what function F is, right? So you got to copy it down. This button right here. So I copy it down. Right now my function is Y. Ooh, we don't want Y. Remember the problem function name is C. So I'm going to have, make C of X. A few reasons why I'm making X as opposed to T. I like to keep it as an X so that I do not have to change these X's on the right side of the equation. If you want to change that X as a T, you're more than welcome to do it, but you have to change these X's as a T, that X as a T as well. Another thing, notice I'm keeping my function as a lowercase c. That's just my preference. I don't like to use capital in the middle, so because I can tell Desmo whatever it is. All right, go to number C, and I'm going to type this in. So I'm going to do the fraction. C of 12 minus C of 8 divided by 12 minus 8. So my answer, I got negative 1.75. So this one I got negative 1.75. A few things. Express your answer as decimal approximation. Yes, that is a decimal. I don't have to round it up because that was an answer. Show the computation that lead to your answer. So whatever I put on decimal, I have to show that it show to the grader what I put it in. Remember, I put C of 12 minus C of 8 divided by 12 minus 8 equal to that. So you can put that in. This perfect answer right here. You're showing what you plug it in decimal, and you're showing what answer you got. Okay, don't use this one. Like, don't write this as a work only. Like, you can't write your answer like this, right? Because it's not function F, it's a function C. So show the work that's necessary. Next, use the average rate of change found in 1 to estimate the number of customers on hold when T is equal to 6. Okay, so I'm gonna pause for a second. So if you look at, hold on. So we are estimating when T is 6. And we found the average rate of change between 8 and 2. Okay, 12. Alright, so there's my graph, which looks very weird. Why does it look weird? Because I don't see the whole thing. Remember this button right here? Zoom fit. If I click it, everything looks really nice, so I can kind of see it. So we were finding the slope of a line between T is equal to 8, this one, and T is equal to 12. So it was, boop, you can't see, but a straight line was drawn between those two. And what was the slope of the line again? It was negative 1.75. Okay, I'm going to draw that on my paper here. Give me 1 second. I need my paper. I know you're like, what is that sign? I don't know what's going on. 1 second. So that was 8,25, and this was 12,18. Okay, so hopefully the transition is working. There you go. There's my graph. What I did was that I find the slope of a line that connects those two, and the slope was negative 1.7. Wow, negative 1.75. We're going to use this line to estimate what happens when T is equal to what? 6. Okay, so use this line to estimate what's going on over here when T is equal to 6. Yeah, all right. So what do we need? We need y is equal to y1 plus m x minus x1. M is a slope, negative 1.75. You need x1, y1. That's a point that your function is passing. Remember, you have 2 points. You can use 8,25 or you can use 12,18. I don't care which one you use. I think Mr. Bear used this one. Use this one. I'm going to use that one. Why not? You should get the same answer. So there's my x1. There's my y1. Oops. So 25 plus that times what x bar we are reevaluating when x is equal to 6 minus x1 is 8. So that's what I plug it in. I wish I have a decimal with me over here, which I don't. Oh, okay, so I'm going to make it smaller and put that in my calculator. Ready? So on number 4, I'm going to do 25 minus 1.75 parentheses 6 minus 8. I got 28.5. 28.5. Oops. Let's just make sure that's the answer you got on the key. Right here. See, we got the same answer. Yay. So as you can see over here, Mr. Bear used the 12, C of 12. So 12, 8. You still got the same answer. Right here. Oh, he used that one. Yay. All right. Next question. I'm going to actually put this out so I don't have to go back and forth. Consider the average rate of change of C from 0 to k minutes where t is between 0 to 2. Are these average of change less or greater than the average rate of change between 8 to 11? Explain your reasoning. Okay, so go back to my graph again. Hold on. Sorry, I keep going back and forth. I just need to make sure I have a correct graph. Where are you? Okay, so it's not passing x-axis. Okay, so I'm going to use the same graph, but let's make it a little different. Okay, so that was 8 over here. That was 12 over here. We found the average rate of time between these two. And the problem is asking me, I'm so sorry, between 0 and 2. Between 0 and, I don't even know, 2. I'm sure it's somewhere there. So slope of this line. Okay, so the question is asking me this. Which slope is bigger? Clearly, do you see this is negative slope? Negative average rate of change. What about this? That's the positive average rate of change. So wouldn't the average rate of change between 0 and 2 be greater than the average rate of change between 8 and 12? Like, I don't even have to compare different things because that's positive, that's negative. Obviously, that's bigger than that. So I'm going to say that average rate of change when t is between 0 and 2 is greater than, I'm using a lot of short language, between t is equal to 8 and 11, because average rate of change between 0 and 2 is positive, wireless, you get the point, wireless, this average rate of change is negative. Okay, to strengthen your answer, you could have actually graphed this along with your answer, because visually it makes so much more sense. Okay? But graph itself is not sufficient. You have to explain what's going on. Last one. The local company wants to use the model C to make a prediction about the number of customers on hold beyond t is equal to 12. Based on this information, what is the largest integer value of t for which the model C is appropriate model? Give a reason for your answer. Okay, so we are looking at beyond t is equal to 12, which was here. Okay, so the question is asking, after 12, how long is it valid? Well, I'm looking at it, it's a quadratic. So at some point, the number of customers is going to become negative. Folks, is that even possible? No. So when does it become negative y value? Your 0 happens 15.555. But the question wants me to say what is the largest integer value. So 15.555 is not an integer. The integer value between 12 and 15.555, the largest one is going to be 15. Right? So I'm going to say for t is less than or equal to 15 because at t is equal to 15.555, the number of customers becomes negative, which does not make sense. Okay? All right. Hope that was helpful. Bye.